Hello and welcome to another Algebra 1 video tutorial. In 10.5 we'll be solving systems by multiplication. The big idea would be an effective first step in solving some systems is to multiply both sides of one of the equations by a carefully chosen number. Now last section when we needed to get the opposite of an equation, instead of subtract 2, we just multiplied one of them by -1 so we get opposites. That's kind of the idea here. We're just getting a little more advanced by using a little more multiplication than just -1. So remember, there's three forms of equations for lines. We have standard form, ax plus by equals c. So be an example like this. Slope intercept and point slope. Now remember, as long as you have opposites, what you learned in lesson 10.4 would work beautifully to solve this, and what you learned in lesson 2 and 3, substitution, worked great for slope intercept. But what if we get where they're not opposites? We have 3x, 6x, minus 4y, minus 5y. We don't have a pair of opposites, so what will we need to do? Let's try and solve that system, and we use multiplication. We need either the 3x and the 6, we need the x's to be opposites or the y's to be opposites. We can use the addition method to eliminate a variable. So what you need to do is carefully choose something. If we'd have to multiply both of these numbers by something to get them to be opposites, but all we'd really have to do is multiply the top equation by -2 to make that -6x. So we multiply both sides by -2, and our new system then is -6x plus 8y equals -14. The bottom one is going to just stay the same as 6x minus 5y equals 20. And then we just go ahead and add like we did in lesson 4. So those add up to 0 is what we wanted. 8y and plus or minus 5y is 3y. And -14 plus 20 is 6. Divide by 3. Divide both sides by 3, we get y equals 2. Once we know y equals 2, we can use one of the original equations, or either these two or either these two. I'd probably use the top one just because it has the smaller amount of numbers. So I'd go 3x minus 4 times 2 equals 7. 3x minus 8 equals 7. Add 8 to both sides. 3x equals 15. And divide by 3, x equals 5. So my solution would be 5, 2. And you could check that if we needed to. Okay, and the next example, let's solve the system 2x minus 3y equals -1 and 6x minus 2y equals -24. So we need to either get the y's to be opposites or the x's to be opposite, and it wouldn't really matter other than we'd have to multiply both of these by something to get them to be opposites. So if you can only multiply one equation, that's what we're looking for. And if we only multiply the top equation by -3, we'll get these to both be this to be -6 and this to be a 6. So -3. All right. So my new system is going to be -6x plus 9y equals a positive 3. Bottom one won't change. 6x minus 2y equals -24. Then what we'll do is we have a pair of opposites, so we can add these two equations and get 0x 7y equals -21 divided by 7, y equals -3. Probably use the top equation to figure out what x is, so I'd say 2x minus 3 times -3 equals -1. 2x plus 9 equals -1. Subtract 9 from both sides, and you get 2x equals -10. Divide by 2, and x equals -5. So my solution is -5, -3. And you can plug these back in and check in to see if it works in this system, and it should. Alright, solve the system 6m plus 5n equals 38, and 4m minus 7n equals -16. So we're trying to get the m's to be opposite or the n's to be opposite. They're at least opposite signs here. So there's not 6 isn't a multiple of 4. So we either have to multiply it by like 1.5, which we don't really want to multiply by fractions if we don't have to. So what we can do is we're going to multiply both equations by different numbers. And I would probably multiply the 5 and the 7 to get them. They're already opposite signs. So we either got to make these two into 12m's or these two into 35n's. It doesn't matter. One's going to be positive, one's going to be negative. So let's do the second way. It doesn't matter. It will work either way. If you made this into a 12m and this into a -12m, So times the top by 2 and the bottom by -3. But let's just multiply the top one by 7 to make this 35, and the bottom one by 5. Okay, top one by 7, bottom one by 5. And our new system is going to be 42m plus 35n equals 7 times 38, which is 266. Bottom one's going to be 5 times 4, so 20m minus 35n equals -80. And now we've created a pair of opposite variables, so where if we add these, a variable will eliminate. So we're going to get 62m equals 186. Yeah, 186. Divide both sides by 62. And m equals 3. All right, m equals 3. Use one of these equations. Probably the bottom one appears to have the smaller amount of numbers. So 4 times 3 minus 7n equals -16. So 12 minus 7n equals -16. Subtract 12. So -7n equals -28. Divide by -7. So n equals 4. So the solution would be 3, 4. Mn is 3, 4. Plug those back in and make sure they work, and they should. Okay, let's say a homeowner wishes to put 6 new lamps around their home. They wish to use a total of 15 light bulbs. Lamp style A uses 2 bulbs, and lamp style B uses 3 bulbs. Can the homeowner use a certain number of each kind of lamp and use exactly 15 bulbs? If so, how many lamps of each style will she choose? So we're going to need a system of 2 equations, and we're talking about lamp style A and lamp style B, and we need 6 lamps. So let's say A number of lamps of style A, B number of lamps of style B, is a total of 6 lamps. Then let's do an equation talking about 15 light bulbs. Okay, so lamp style A, for every one of them, is going to use 2 bulbs, so we're going to say 2A. And every lamp style B uses 3, so plus 3B equals 15. Now, what you would want to do is try to get to be a pair of opposites, and you could either eliminate the A or the B. It's going to be about the same amount of work. Let's use smaller numbers if we can. So let's multiply the top one by -2 to create this to be -2A. So now my new system would be -2A minus 2B equals -12. The bottom one isn't going to change. We didn't need it to change. Add these together. A's cancel. -2b plus 3b is just 1b, and -12 plus 15 is 3. B equals 3, so we're going to need 3 of style B. Well, A plus 3 equals 6. Subtract 3. A is also 3 if you couldn't do the mental math on that. So we need 3 of each. 3 lamps of each style. Okay. All right, solve the system. N minus 3 equals 3/2 m, and 4m plus 5n equals -31. Now, notice this one is not really set up for the multiplication and elimination method. So, would substitution work better, or can we rearrange this to get it to use the elimination and multiplication method? This is just n and minus 3, so this would be pretty easy just to add 3 to this equation and make it n equals 3/2 m plus 3. And now I have a variable by itself that would be easily substituted into the bottom equation. So probably the substitution method would work best here. So I'd end up with 4m plus 5n, and I'm saying is 3/2 m plus 3 equals -31. Now I have an equation with one variable. I can solve this for m. So 4m plus 15/2 m plus 15 equals -31. Add these m's together. Let's make this half. So this will be 8/2. 8/2 m plus 15/2 m is 23/2 m. And in the same step, I'm going to subtract 15. So I'm going to make this -46. Then we need to times by the reciprocal, or divide by 23/2, but let's just multiply by 2 23rds. and I'm going to get m equals negative 46 divided by 23. That is negative 2. Negative 2 times 2 is negative 4. So m equals negative 4. Probably use this equation would work best to figure out what n is. So n is going to be 3 halves times negative 4 plus 3. So this will be negative 12 halves is negative 6. Negative 6 plus 3 is negative 3. So my solution is negative 4, negative 3. Okay, now let's say you decided to go the route of rearranging this to use the multiplication and elimination method. Well, you would need to, this one's set up good. It's in standard form. 4m plus 5n equals negative 31. The top one's the one we need to rearrange. So we'd subtract 3 halves m from both sides. Then we have a plus n. Then we'd have a minus 3, but I want to add 3 to both sides. Right now I have 0 over here because I've subtracted 3 halves m. So I need to add 3 to both sides. So now, this, and bring over the other equation, the bottom equation, because I didn't need to change it, would be a new system in standard form where we could use the multiplication and elimination method. And in this case, I would probably multiply, these are going to be hard to get to be opposites without fractions, so I would probably multiply the top one by negative 5 so I can create a negative 5n. So this is going to be a positive 15 halves m minus 5n equals negative 15. The bottom one won't change. 4m plus 5n equals negative 31. Now go ahead and add those together because we've created a pair of opposites. And we're going to get 15 halves m plus 4m. That's going to be 8 halves plus 15 halves. So that's once again our 23 halves m gone. Negative 5n plus 5n. And then this would be negative 46. And then look where we're at. We're back where we were here in basically kind of about 2 steps to get this. So it's really going to get you in the same spot. It's just what first couple steps are you going to use to get there. Okay, so it would have probably been about the same amount of work whether you use the multiplication method or whether you use the substitution method. It'll be your choice. You'll have a couple of different ways that are acceptable to solve that. All right, that wraps us up. Your assignment will be 10-5, page 612, 2 through 22 evens. Thanks for watching, and we'll see you next time.